Hi everyone, in this video we're going to find the inverse function for the following functions. I've got a few examples here. First of all, I'm going to find the inverse function for the f(x) equals to -6x minus 7. To find the inverse function, I'm going to start from this statement, that is a composite function of the f inverse equals to x. So how do we get the inverse from this statement? I'm going to put f inverse in the bracket first, so that you can see obviously that actually now at the left hand side we're going to find the f inverse. So f inverse means that you can understand in this way. The x will be replaced by f inverse, the same thing as this x. This x is going to be replaced by f inverse. So my f inverse will be equals to -6 f inverse minus 7. Because this x has been replaced by f inverse, and this is equals to x. Alright, then I'm going to find the f inverse, so I will try to make my f inverse as a subject. Here I have a x plus 7 and divided by -6. Alright, so this is your f inverse. For this function, again, I will start from the f inverse equals to x, yeah? Okay, start from put a bracket for the f inverse, and this is equals to x. Alright, so you can understand in this way. F inverse, in the bracket you got f inverse, right? So meaning that the x here is replaced by f inverse, and the same thing over this x is going to be replaced by f inverse. So now I'm going to write f inverse as -2/5 f inverse x plus 3, and this is equals to x. To get the f inverse, again, I will try to make my f inverse into the subject. Firstly, I got -2/5 f inverse equals to x minus 3. And then my f inverse of x equals to 3 minus x. Okay, 3 minus x meaning that I multiply both sides by negative first, and then multiply by 5/2. Okay, bringing the 5 to the right and bringing the 2 to the right. So I have my 5. 3 minus x over 2. This is my f inverse. To get the inverse function for this quadratic, since this quadratic already completed the square, it already in form of completing the square, so we can directly find this inverse function by using this statement. So again, I'll try to put my f inverse into the bracket. And from here, I know that this is going to be f inverse. F inverse is going to be same as f, and then the x will be replaced by f inverse. The same thing over this x. Yeah, when this x is changing, this x also changes to the same thing. So I have my f inverse can be written as f inverse -1 squared -2. If this is equals to x. Okay, so now we try to make the f inverse as the subject. I got my f inverse -1 squared equals to x plus 2. And then to eliminate the square, I got my f inverse -1 equals to positive negative square root of x plus 2. Alright, then after that, I got my f inverse, okay, equals to positive negative square root of x plus 2 plus 1. And this is not yet the final answer, because f inverse cannot be positive negative square root of x plus 2. You always can check whether you want to choose the positive or negative one by referring to the domain of the f. The domain of the f is equals to the range of the f inverse. Okay, from here you know that the domain of the f and the range of the f inverse is actually equals to -infinity up to 1. Okay, from -infinity up to 1. So if you want to know, okay, which one you will choose, okay, since the range of the f inverse is -infinity up to 1, meaning that you want to get a value which is less than or equal to 1, the y value. Choose the one which will gives you the y value, where the y value is from -infinity up to 1. Since here we got the positive square root of x plus 2 plus 1, we got two choices. One is a positive square root of x plus 2 plus 1. The other choice is a negative square root of x plus 2 plus 1. So in order to get a function which will give you the range where the x is less than or equal to 1, this is the one. Okay, only a negative value plus 1 will give you a value which is from negative infinity up to 1. If this is a positive, so positive number plus a positive number always will produce positive number. But our range show that we have the chances to get a negative number. So we will choose the second function, which I will make my conclusion. Since the range of the f inverse is negative infinity up to 1, so my f inverse will be equal to negative of square root of x plus 2 plus 1. This is my final answer. For this quadratic function, we also will apply the same method. Okay, I will find f inverse. So f inverse again, put this as your f inverse means that this x also need to be f inverse. So this statement at the left hand side will become 2 f inverse minus 3 square it and minus 5. Follow the function, and this is equal to x. Now we need to get the f inverse, right? So I will try to eliminate the 5, meaning that bringing the negative 5 to the right side, I got x plus 5. And here you have 2, you divided by 2. So now you can see that you want the f inverse. You will eliminate this square by taking the square root. So you will get the positive negative square root of x plus 5 over 2. And then don't forget you have to plus constant 3. So this is the two choices that you have. The first function is positive square root of x plus 5 over 2 plus 3. The other choice is a negative square root of x plus 5 over 2 plus 3. So which one you will choose? Again, I will refer back to the domain as is given here. So again, the domain is s greater or equals to 3, meaning that domain of f is equals to the range of the f inverse, and this is equals to 3 to infinity. I always will convert this interval into this form so that it won't confuse me by the symbol of x. Here, okay, I state again, my range of the f inverse is from the 3 to infinity. So which one will give you, which of the function here, either function 1 or function 2, which of the function will give you the range 3 to infinity? Look at this, positive. If this is a positive value plus 3, it will always be a value which is greater than 3. But if let's say this is a negative, right, because you have a negative in front of the square root, so this will produce negative number. A negative number plus the constant 3, it will always a value which is less than 3. Alright, so I will choose the first function, which it will produce a 3 to infinity. So my conclusion is the f inverse will be equals to the positive square root of x plus 5 over 2 plus constant 3. For this quadratic function, since this is not yet in completing the square form, right? We need to do completing the square. Okay, how to do completing the square? We'll check the coefficient of the s square to make sure the coefficient of the s square has to be 1. And then now it already become 1, right? We can start completing the square by just copying the first two terms and then put a positive bracket square, negative bracket square, plus a 6. Okay, after that, what should I fill in this bracket? I'm taking the coefficient of the f, that is 94, and both are divided by 2. Then the first three terms, it can be written as x minus 2. I'll take the negative 2 from here, because negative 4 divided by 2 is negative 2, yeah? And then this has to be squared. So when you square it, you will get back these three terms. Then simplify the constant. You have a negative 2 divided by negative 4 divided by 2, that is negative 2. Power of 2, that is negative 4. Negative 4 plus 6, that will be positive 2. So you have done it now. Alright, so our inverse function will based on this function that we have converted into the completing the square form. Okay, so start from this statement again. Start from finding the composite function of this f of f inverse equals to x. So what is the means by the F inverse? That will be mean by the X will be replaced by the F inverse. Okay, then after that, my F inverse will be equivalent to negative, F inverse minus 2, and then square it, plus another constant 2 equals to X. Yeah, F inverse will be like this, and right hand side remain as X. After that, try to make the F inverse as the subject. So I got this X minus 2. Then now we make it we square, taking the square root. Okay, I got positive negative square root of X minus 2. So my F inverse will be equals to either positive or negative square root of X minus 2 plus 2. So again, I got two choices. The first one is a positive square root of X minus 2 plus 2. And the second choice will be negative square root of X minus 2 plus 2. Again, to decide, to determine which function should be taken, we're going to check for the domain which is given. The domain for the f is x is less than or equals to 2. From here, we know that the domain of f is equals to the range of the f inverse. And just now, the question gives us s less than or equals to 2, meaning that our domain will start from negative infinity and stop at this rate. Okay, stop at 2, sorry. And now we need to consider which of the choice that given here, which of the function given here, 1 or 2, alright, will gives you the range from negative infinity up to 2. Meaning, okay, so look, consider this this interval. You got the chance to get negative value, right? You can get a negative, any negative value up to 2, or even 1 also can be taken. Even 2 also can be taken. So look at the function, the first function. If you have a positive square root of x minus 2, this will always produce positive number. If a positive number plus 2, it always will get a number which is greater than 2. For the second function, if this square root taking the sign of negative, meaning that this will produce negative number. A negative number plus 2 means that you will always get a value which is less than or equals to 2. So the second function will fulfill our range of the F inverse. Finally, I will make my conclusion. Our F inverse will take the negative square root of x minus 2 plus 2.
Let us move to the F example F, and now I'm going to get the F inverse for this function. Again, I'll start from this statement: F inverse equals to x, and then we put F inverse in the bracket. So from here, the left hand side, obviously you can see that F inverse is actually putting this x as the F inverse, and the same thing as this F. This x also will be replacing by this F inverse. So I will have my F inverse as this: negative square root of F inverse minus 1. And this is equals to x. After that, I'm going to get the F inverse as a subject. So I will multiply both sides by negative 1 first. I got my negative x at the right side. And to eliminate the square root, I will square both sides. Square both sides, you will have a right hand side as a negative x squared. You will have a positive x. Alright. And finally, you got a F inverse equals to square it, meaning that negative x squared. Okay, you will get the x squared, and after that, to get the F inverse, you will have a F inverse equals to x squared plus 1. Alright, so this is our inverse function. For this example, again, we're going to start from the F inverse equals to x. Okay, so to get the F inverse, actually, this x will be replaced by F inverse, and the same thing over this x. So I got my 2 minus square root of F inverse. Okay, so the x replaced by F inverse, I got this, and this is equals to x. Finally, I got my F inverse. square root of f inverse equals to 2 minus x. Then in order to get your f inverse, you square both sides. You have your f inverse equals to 2 minus x squared. To get this, again, same step. I'm going to start from the f inverse equals to x. Then after that, I will get the composite function for the f inverse. That will be the f inverse cube. Okay, plus 2. This is equals to x. And our purpose is to get the f inverse, right? So I will move the 2 to the right side. I got x minus 2. And the f inverse will be equals to the cube root of the x minus 2. For this function, f inverse will be equals to f inverse minus 2 power of 3. This is equals to x. And to get the f inverse, I will have x cube root of x. All right, take the cube root at both sides, and then plus 2. Add 2 at both sides. We have a cube root of x add by the 2. Okay, last example. To get the f inverse, that will be 4 cube root of the f inverse. This is equals to x. So divide both sides by the 4. I got my x over 4 at the right side. And to get the f inverse, I take cube at both sides, meaning that I got the x cubed over 64. All right. For this question, we have given the function fx as this quadratic function, and sketch the graph of f. All right. So now we to sketch the graph of quadratic. Yes, this is in a perfect form that we can sketch our graph easily from the function given. This graph having the shape of the minimum point, because from the coefficient of this x squared, we can see that it has a minimum point, and the minimum point is given by the 1, 4. Taking the value of here to be the coordinate of the x, okay, x coordinate, that is changing the sign over here, I got 1. And taking the 4 directly from here, you have the y coordinate. So we are plotting this graph at the 1 unit for the x-axis and 4 unit for the y-axis. And the shape is a minimum point. We have a parabola passing through this minimum point. Then we can label this as y equals to fx. And now we have done the part A, that is sketching the graph. Part B, determine whether the inverse of f exists or not. So from the graph given by the question, we might know that this is not a one-to-one graph. Okay, we can check by using this horizontal line test. Just sketch a horizontal line, and you can see that your horizontal line passing through this curve at 2 points, meaning that you have to make your conclusion. Since the horizontal line, from the graph and from the horizontal line test, we see that the horizontal line cuts the curve y equals to fx at more than 1 point, or we say 2 points. F is not one-to-one function. Thus, we say that inverse does not exist. All right, so this is our answer for the B. Determine whether the inverse of f exists or not. So we say that inverse does not exist, because we must give the reason. Yeah, give the reason why we say so. So we actually make this conclusion by considering the horizontal line test. For this example, we have given a function, a quadratic function, 2x minus x squared, where x is greater or equals to 1. We know that for any quadratic function, originally it is not one-to-one function. So to make it one-to-one function, we must restrict the domain. So now this question already restricted the domain to become the domain x is greater or equals to 1. Question asks us to show that the f is one-to-one function, and hence find the f inverse. So firstly, I will use a graphical method to show that it is one-to-one function. So sketch from the graph. to sketch this graph, I will first get the root of the graph first, because I can see that the function given is very simple to solve for the root. So I factor out the x. I got a 2 minus x, and then solve it. I got x equals to 0 and x equals to 2, meaning that there are two roots. One is at the 0, 0, the other one is at a 2, 0. Okay, so the graph, it will be like this form. It will be maximum point because of the coefficient of the x. The coefficient of the x square is a negative, meaning that the shape of the graph has to be open downwards. Okay, when you open downwards, it has a maximum point. All right, you just sketch. You just need to sketch the graph having the maximum point, and then passes through the two roots and go down again. So what is the maximum point over here? You can find it easily. Okay, we can actually, the maximum point is at the symmetry, the axis of symmetry of the parabola. Okay, so axis of symmetry, meaning that it will be at the middle of the 0 and 2. So at the middle of the 0 and 2, that will be 1. Okay, in between 0 and 2, there's a value in the middle that is 1. So meaning that the maximum point happen at the x equals to 1. To get the value of y, very simple, we just substitute x equals to 1 inside. Put the x equals to 1 inside. You got the 2 minus 1, that is 1, meaning that the y value, the maximum point, having the coordinate 1, 1. You can see that originally this curve, right, this parabola curve, when you use a horizontal line test, the horizontal line will pass through 2 points, meaning that this is not one-to-one function. So now the question restricted the domain to become x greater or equals to 1, meaning that at the 1 here, at x equals to 1, it cuts the graph at two parts, okay, into two parts. That is, it will break at the x equals to 1, and since the domain is having x greater or equals to 1, meaning that we only takes the right hand side, the graph at the right side, and the rest we will just delete. Okay, just delete, and we just remain the graph at the right side. So now the graph become in this shape, and you can see that if, let's say, now I use a horizontal line test, right, you can see that my horizontal line only passes through the graph at only 1 point, no matter how many horizontal lines you have drawn. Okay, so our conclusion is, since the horizontal line cuts the curve at 1 point, then we say that f is one-to-one function. Okay, so thus you might make conclusion. The inverse exists. Okay, sorry, inverse exists. Okay, so since the inverse exists, we are now the question asks us to get the, hence find the f inverse, right? So based on the function, we need to do completing the square first in order to get its inverse. Fx is given as a 2x minus x squared. So in order to do to find the f inverse, at first I will try to completing the square first. To do completing the square, I have to make sure the coefficient of the x square has to be 1. So I got my x squared minus 2x in the bracket. So now the procedure of the completing the square will be done in the bracket. I will have x squared minus 2x and copy down the first two terms and add in the two brackets. One is positive, the other one is negative. Since there is no constant, right? So just close your bracket like that. And what is number that you need to fill up in the bracket? You are taking the coefficient of the x, that is negative 2. And both of them you are going to divide by 2. This is the procedure. Okay, so the first three terms here, you're going to simplify into x minus 1 squared, where you get the negative 1 from here. You get the negative 1 from here, that is negative 2 over 2. And then minus negative 1 squared, that will be 1. Negative 1, the negative is come from here. Negative 1 squared will be positive. All right, multiply your negative inside, you got the negative x minus 1 squared. Negative multiplied by negative, you got positive 1. So now we can start to find our f inverse by finding the f inverse equals to x. Use this statement. So to get your F inverse, you're going to replace this x by the F inverse. The same thing over this x. So you will have a negative of F inverse minus 1 square it minus 1 equals to x. Okay, plus 1, sorry, positive 1. Okay, so now to get the F inverse, I will first minus 1 at both sides first. I got my x minus 1 in the right side, at the right side. And then multiply both sides by negative 1. I got my 1 minus x. To get your F inverse, I'm going to square root, take the square root, positive, negative square root of 1 minus x. And F inverse will be equals to positive, negative square root of 1 minus x plus 1. And again, this is not yet your final answer because we got two choices. One is a positive 1 minus x plus 1. The other one is a negative 1 minus x plus 1. Again, I will refer back to the domain is given by the question. The domain given is x greater or equals to 1, meaning that the domain here, domain of f is equals to the range of the F inverse, right? So given by the question is x greater or equals to 1, meaning that it will be start from 1 to infinity. Okay, I would like to convert into this interval form so that I can see clearly. Okay, now, so F inverse, I'm going to make conclusion F inverse will be either taking the first function or the second function. The first function given here is a positive number plus positive number. For sure, it always will be positive. And the second function is a negative number plus 1. So it will produce negative number and it has a chance to get 1. Okay, so looking at this range of the F inverse, which one will produce the range which is a 1 to infinity? The first one. Because the positive number at 1, you will get a positive number which is greater or equals to 1. So I decided to choose the first function. Then you make your conclusion. F inverse is equals to positive square root of 1 minus x plus 1. This is your final answer. Thank you for watching.